Okay, this one section is also really important. This is going from grams to moles and moles to grams and moles to volume relationships. So you've seen these jelly jars where you're trying to figure out how many jelly beans are in that jar, and you get to win a great prize. So you kind of think, oh, how much is the size of one jelly bean, and what's the overall volume of that container? And you try to think in your mind how many are in there. We do the same thing with chemistry all the time. We use the relationships of mole, mass, volume, and number of particles to solve tons of problems in chemistry. So this is really, really key to chemistry. So we're going to convert mass of a substance to the number of moles of something. This is a basic thing that we do all the time, and we're going to use the molar mass to do that. Remember the molar mass? We had to calculate that on the last set of slides I worked with you guys on. So we do the same thing here. We're going to take mass is number of moles times the molar mass. So remember, this is mass over 1 mole defined as molar mass. We had to figure out what the molar mass is based on the periodic table for atoms and for molecules. We did that in the last section. So we can find moles by taking mass and flipping this molar mass upside down, and the grams can cancel out, and we'll come up with moles. So we can flip this thing however we need it in the problem to get where we need to get to. So say I have a mass of that many moles of aluminum oxide, and I want to know what the mass is. Say I have this many moles, and I want to get the mass. So I'm going to have to figure out the molar mass of this guy first, and then I can do the problem. So I'm trying to figure out mass, but I have moles. So we can do that a lot. We can go moles to mass. This is basic things we do all the time. So we're going to take our given. We're going to put it down here. We had 9.45 moles was the given in the problem. We go on the periodic table, figure out 2 aluminums plus 3 oxygen numbers, and get this answer. So I need you guys to try this yourself with your calculator, pencil, and paper. This is something we have to be able to be really good and fast at because we use it all the time. If you notice, the mole cancels out because one's here, one's there. If one's over the other, they cancel out. And then the moles cancel and you get to grams. So in your calculator, you're going to take this number and multiply by that number, divide by 1, and you'll get that. 3 sig figs here, 3 sig figs there. So this I need you guys to get good at. So please, please, please practice this. Make sure you can do this type of problem. So you could try that one yourself. That would be a long one because you'd have to do 20 C's and 42 H's. See if you can try that one all by yourself. Same process. So now let's go convert mass to moles. So in this one, they gave us rust. That's rust. And they gave us grams. And they want us to find moles. So we're going to work on this one. Given mass, finding moles. Given mass, finding moles. So what do you think we need to do first? I would imagine we're going to need to find this molar mass off the periodic table. 2 irons, 3 oxygens added together. So that if you do that, you should try this yourself. You'll get this many grams. And then we're trying to get rid of grams. So grams is going to go on the bottom. We flip this molar mass. So we have 1 mole on top, the grams on the bottom. Grams cancel. And we're coming up with moles. So 3 sig figs, 3 sig figs. So try that yourself. Pause the video, see if you can write this out. It'd be really good if you wrote it out on paper because it'll go into your memory better if you actually write, listen, see. As many senses as you can use. If we could have smell and vision for learning, it'd be great too. The more senses you use when you're trying to learn something, the more it'll go into your memory. So try to use as many as you can. If you could speak out the words while you're writing, that'd be even better. Okay. Here's another problem you could try. So this STP thing is talking about gases. There we go. Oh, there we go. Sorry. This is talking about we're going to use a mole-volume relationship in gases. This thing right here is very important. It stands for standard temperature and pressure. It's just something to know what the numbers are. So Avogadro did this with gases. He said that if you have two different gases, it doesn't matter what they are. If you're at the same temperature and pressure, that standard temperature and pressure, you're going to have the same number of particles. So same number of little balls, no matter what they are, there's going to be the same amount. So Avogadro, this is Avogadro's gas law. Volume of gas varies with temperature and pressure. Because these two things are the same, then the number of particles is going to be the same. So this is what I need you to memorize. STP means 0 degrees C, which is 273 degrees Kelvin. 0 degrees C, 273 degrees Kelvin, and a pressure of this or this, they're equivalent to each other. This is something to memorize. So put this on a note card to memorize as well, along with your polyatomics and how to figure out molar masses. So there's quite a few things. And the diatomic atom gases, that would be good too. So those are all things to start putting on flashcards and memorizing. So STP is another good thing to put on a flashcard and memorize. So this is what we need to know. At STP, at these conditions, a gas will be that many particles. 1 mole, that many particles will occupy this volume. This is something to know, because sometimes you'll have a problem that says the gas is a STP and you want to know how many moles there are, or what volume it is. This little relationship, 1 mole of a gas at STP is that many liters, really makes the problem easy. So 1 mole of gas is that volume that this person's holding. Okay? And that's called the molar volume of a gas. It just means 22.4 liters is how much a mole occupies. So we can use this relationship. But you have to be at STP. So that's the caveat. Okay, so here's a problem. We have this many moles of a gas at STP. Doesn't matter what gas it is. All gases at STP occupy that 22.4 liters. So I have that many moles. I know this relationship. So I can use that conversion factor. Okay. So that many moles, 2 sig figs, and every mole at STP is 22.4 liters, so I can take the moles, cancel out, and I can come up with liters, 2 sig figs. So see if you can try this problem, setting it up and understanding how we're doing this. The moles are canceling and we're coming up with volume, which is liters. So the only reason we can do this relationship is because we're at STP. So look for that STP magic words in the problem, because you can use this magic quick conversion. Here's some other ones to try. So now we're going to talk about molar density. We can talk about density of gases using that fact that we just did, and we can use a molar density. So they're saying this is the molar density of a gas at STP, and we want to know the molar mass. So they gave us the density grams per liter. We know we're at STP, so we know this. 1 mole, that. And we're trying to find the molar mass, which is grams over mole. So if I do grams over liters, and then I have that magic relationship of liters over 1 mole at STP, the liters are going to cancel, and I'm going to get to where I want to be. I want to be grams per mole, which is molar mass. So if I multiply those two things together, I'll get grams per mole, which is molar mass. So grams over liters, and that magic info about STP, and then I can go and find the molar mass. This has 4 sig figs, so this answer should have 4 sig figs. This I need to fix, sorry about that. So 4 is given. This was given in the problem. So whatever's given in the problem, not any constants is a constant. We know this one, but this one is the given. Our answer should have 4 as a given. I think they're rounding because they have 36 here, so maybe that is okay. I have to think about that one. All right. So here's some relationships. Molar mass is that mass of 1 mole. So you can flip it this way, grams over mole, or you can have mole on top, grams below. You can use this volume of a gas relationship. 1 mole at STP is 22.4 liters. You can flip the fraction however you need for the problem. And then you know that 1 mole is that many particles. So we can use all of these things. Some people like to use this mole roadmap, so you might want to take a picture of that or print this page out for yourself so you can figure out how to go from one place to another in a problem. So some people like to use this, they like this mole roadmap. So if this is something you like, you're a visual person and you like this relationship, please use that for yourself. Some quizzes and tests I allow notes, so this might be something that you want to put on your notes. Alright, let's try a quiz. So this one, you're going to have to stop the video and you're going to have to do the math for this one. So probably pause me right now, do the math, come back and see if you get the right answer. This is for water, H2O. So you got to find the molar mass of water. So pause me and now I'll give you the answer. So see if you can get that correct answer. Next problem, you're going to have to pause me again. We're trying to find the moles knowing grams. So we're going grams to moles. So see if you can try this problem. Pause me and then try this one out. See if you can get it. So this is a big molar mass, so you're going to have to figure that one out. Take you a little bit. So you should get this answer. Alright, now we're going to use that magic 22.4 liter relationship for STP. 1 mole is that, and use it here to get a volume. So pause it, try to do this one yourself, and you should get this answer here when you're done. Alright, it was good talking to you. This is an important section. I know I keep always saying this is important, but this one, especially for those folks who aren't, loving the math, this one is something to work on so that you get proficient at it. So anything in chemistry is just, it's not that hard. It's just, you just need to practice, practice, practice. And if something is not your fave, sometimes you just need to practice it more and it'll become more fun. Well, to me it's fun, but maybe less difficult for you. So do your best, and please, if you're having trouble, come see me and talk to me in office hours, and I will help you so much. Sometimes it's just good to talk through a problem. So talk to someone, one of your lab partners, or talk to me, and we'll get you straightened out. So please never feel worried about coming to talk to you. All right, I'll talk to you soon. Bye-bye.